Greetings, hello, and welcome everyone. Welcome to DevChatter. My name is Brendan, as it obviously says right here, and this channel, of course, is DevChatter. And if you are someone that is new here, I want to welcome you to the stream and let you know that we do a lot of stuff here, and we try to keep it both fun and weird. And we will be doing some interesting stuff today. If you have questions, we want to welcome you to ask them. It's Our community here at DevChatter is very welcoming and open to answering questions and things like that. So if someone on here sees your message, we will try to verbally respond to you, but we also have a lot of awesome developers in our community that are going to be in the chat the whole time talking to you about whatever it is we're doing, because, well, everybody here is interested in learning and doing fun stuff. And I know I mentioned that I am, of course, Brendan. I am the host of the stream, but we are more than just a stream. We're a whole community of developers that obviously are the people in the chat, and they're also in our Discord, so you can check that out to find out more about it. So feel free to join and chat with us, or show up to these episodes, or anything. And you don't have to talk if you want to stay silent. We will not really call you out to do anything. By this point, someone has probably noticed that I'm not alone on this stream. There is some strange bearded man that I assume must have been locked down in quarantine for 20 years or something. He's grown a heck of a beard. That, or it's a hermit, a druid, I'm not sure. Either way, I believe he goes by the name Santa Claus. Wait,
ho,
no,
ho, ho.
I don't know who this guy is. Guy, will you tell us who you are?
Yeah, well, you just told him. I'm Guy, right? Obviously. I should look down like this so that I look like I'm looking down at you on stream, and then when you look
That's
at
the wrong way, Guy.
Yeah.
On the other way.
Oh, did I look the wrong way?
You look the wrong way.
I'm flipped. Okay.
Yep.
Oh well. Okay. Now I'm looking down at you there.
Yes, that is Gimli up
my
there.
name's Guy Royse. Brendan and I have been compatriots. Friends forever.
A little over a decade, I think.
Yeah, and we used to speak next to each other, but not in the same session at Code Mash, and I don't know, we've just been friends forever. And some of you may have seen me on stream before, and I've been trying to do every now and then on a Saturday, coming on and pairing with Brendan and writing some of these inefficient data structures in JavaScript. And the reason they're inefficient is because they're in JavaScript.
And also, we're not really building them as here's the code you want to use. We're building it as hey, here, we're going to build this fun thing together. So we're going to do it in a simple way. We're not going to do any of the crazy optimizations. And, we're building it in JavaScript, where some of the underlying data structures that we need for these other ones existed anyway, and we built alternates for them sort of on top of it.
Like hash table. Everything in JavaScript's already a hash table, because
exactly
that's how they implement objects. And so
yes.
Why would you build a hash table? Well, I mean, the reason really is because it's educational
and fun,
and because it's fun, and it's I mean, I think hopefully it's fun to watch, but it's also fun from it's educational from hey, I can learn how these things work in a language that I'm familiar with. But for myself and Brendan too, I'm sure, building these helps us reinforce these ideas in our mind as well. I had never actually written a hash table before I did it live on stream with Brendan the last time we did this.
I can say the same. I never built a hash table before that exact moment, but I know how they work.
Yeah, I had built linked lists before in C++.
Same.
So, but do you want to do that on stream sometime? I vote no.
Wait, which thing?
In
C++?
C++.
Oh, heck no. No way. No. It's embarrassing enough goofing around in JavaScript to make mistakes. Yeah. As soon as you pull out C++, we'll be shooting ourselves in the foot all day.
Yeah. We'll have enough rope to do it. So, well, one thing I do want to do sometime, though, I think would be a lot of fun on your channel, is to do some WebAssembly stuff, because we haven't done any of that yet. Like some low-level WebAssembly programming. I think that'd be a hoot. So, so what are we building today, Brendan?
Well, I'm glad you asked, Guy. So we put out a poll, and we asked people what they'd be interested in, and of it, so from that poll, we ended up getting very balanced answers, and then we added in my vote, and we ended up with a tie between doing a Bloom filter and a binary heap. So, since Guy knows Bloom filters much better than he knows binary heaps, I think, uh, I assume that
Yes.
Guy does. Yeah, good. I was expecting some kind of confirmation or nod. Uh, we figured we'll do a binary heap next time and start with a Bloom filter. We both like both structures. They're interesting, and they solve very different problems, and have, at least in the implementation we're going to use, they can both be built on structures that we have already created. So we have created the underlying data structure that could be used for either one. So that was part of the reason why the poll I put out on Twitter had the specific data structures it did, is these are all structures that build on top of structures that Guy and I built on stream previously. So we're going to do a Bloom filter.
Do
Guy,
we
do
want
you
to
want
back
to
it with
talk
the?
about it, or do you want me to say what it does?
Well, I was going to ask, are we going to back it with the linked list?
I
Because
assumed
then
we
it
were
would
going to
be.
use our hash table, which has a linked list under it.
We actually shouldn't need to use either of those because it's, the core idea of
We could
the
just
Bloom
use an
filter
array.
is
Yeah,
an array, and if you
we could
use an
hash
array,
into an
then
array.
you get you get O of one operations to
Correct.
read and write to the
I'm
Bloom.
sorry, Guy. I hate to interrupt you here for a second, but I just want to point at something on the stream here. After stream delay, you should see what I'm pointing at.
Yeah, inefficient.
Yes. Why do we? No. Okay. We can put an array under it if you want. I was figuring
Um,
we might use our existing hash table, but we don't need to.
well, I think the linked list. Did we implement a get on the linked list? Let me take a look. Like a get at index.
Let's pull it up. Yeah. I will. Where? Wait. Are you not connected in here anymore?
I believe I am.
Okay. Oh, maybe it's because I don't
Um,
know.
can you? I'm in the linked list.js.
Okay. All
Let
right.
me
I am
look at.
anchored to you.
Okay, yeah, there you are. Yeah, I'm GuyRoyse.com, and you're Brendan at Enric.com. So we're good. Yeah, so yeah, we have a get at. So
Yep.
yeah, we can do that. Do we have a set at? Well, yeah, I guess we do because the get's going to
Because that's
return it returns the bucket, right?
yes.
Trying to remember what we built
Yes.
here.
The get at returns the node that we are storing. So it gets at a specific index.
Yeah,
Let's
so
see.
then it would be node dot.
So
Uh,
congratulations, everyone. This is our momentary review of
yeah,
the previous linked list that we built.
we're super organized today. Yeah.
So we have an isEmpty method, a size method. We have an append, which will add a new item. And this...
Yeah. Okay. Yeah, we can use this. Let's use the linked list. I think this will be fun. Uh,
What did our hash table do? Let's have a look. So in our hash table, what did we do? We said that, oh no, new array, capacity, map, linked list. We did an array of linked lists. That's what we did.
yeah.
So our hash table is arguably more complicated than we need for what we're doing.
Yeah.
Because we don't need the linked list inside the array for a Bloom filter.
Yeah.
Because we
So
don't care if there are extras.
yeah, the
So let's talk about a Bloom filter.
yeah,
Guy,
that's what I was just trying to
what does a
segue
Bloom
to.
filter do?
What the heck's a Bloom filter, and why do I care?
Yeah.
So a Bloom filter is a probabilistic data structure. Up till now, we've built deterministic data structures, right? You put something in a hash table, you can get it back out. A probabilistic data structure They're data structures that have an error rate. They sometimes do not tell you the truth. A Bloom filter acts like a set. So you can, you can add things to a set, right? You've got like a set of numbers, a set of the letters of the alphabet, A through Z. And with sets, you can do things like get their cardinality, to count how many unique items there are in the set, or you can you can get frequency off of them, or you can add and remove members and check for membership and stuff like that.
Mm-hmm.
A Bloom filter acts like a set, but the only thing you can do to a Bloom filter is add things and check for membership. You can't do anything else. You can't pull the items back out. You can't get a list of the items. You can't count the number of items. You can only add things and check to see if they're in there or not.
It's sort of like having I would think of it like if you go to a library and you were looking in their card catalog, for example, and you could look through the card catalog and see, this is what the library is supposed to have. And someone would be like, well, no, there's more information there, because they have on the library card, it's going to say, where in the library, like, the book is. To which I go, no, it's going to tell you where you think that book is. That book might not be there. Someone could have not returned it. It could have been lost. Who knows?
Well, the way the Bloom filter works internally is they hash the thing you're going to put into them, and then the original thing is gone.
Yep. So instead of storing the item like we normally would in a hash table, we just sort of record that it was stored there.
Yeah. The other thing that Bloom filters is there is an error rate in them. And with a Bloom filter, depending on how you implement it, you can choose the number of hashing functions you want to use, and you can choose how wide the bit array is. And as you watch us do this, that'll make more sense. And that will determine the likelihood of the Bloom filter lying to you. Because a Bloom filter, when you ask, is this thing in the set or not, will say, no, it's definitely not in the set. Or it will say, yes, it's probably in the set, but it might be lying.
So to sort of mildly illustrate it in this terrible way of illustrating it, if you imagine that this is the set and we're going to hash down to either 0, 1, 2, 3, 4, etc. along our little array implementation that we have, whatever the hashed value ends up giving us is where we're going to put it. So if the value we put into our Bloom filter ended up hashing to 2, we would change this from a false to a true. And then if we put in our next item and it hashes to a 6, then we'll fill in the 6 with a true value. And the idea then is if someone goes and asks this, hey, what do you have for the value of, let's say the values we put in were foo and bar, and they hash to be 2 and 6 using our hashing algorithm, then we're going to go in and say, oh yeah, I have something at 2 and I have something at 6. So when I check to see if they're in there, it's going to say, yes, I have something in that spot. And you might go, wait a minute, isn't that deterministic? Isn't it telling me it's there? To which I say, no, because 2 different values can hash to the same number just based on how hashing works. That's why in our hash table implementation, we had to have in our array a linked list inside of our array to keep our overflow. So if 2 elements ended up hashing to the same value, we would keep a list of them, and that's how we stored it.
Well, and just to be super precise, the hash itself is going to return like a 32-bit number, which is probably not going to have any duplicates. I mean, because that's the idea behind hashing is you try to get unique numbers. But then we need to do a modulus operation to pull that down to the width of the thing we're going to shove it in, and that's guaranteed to get collisions. And so what you do with the Bloom filter is you could use 3 hashing functions. And so if I put the string foo in, it generates me 3 hashes with from 3 different seeds, and then those hashes then set portions in that bit array that Brendan was just showing you, and then then you check, and they all 3 need to be true. And that means that if there's a collision, it's not as damaging.
Yep. Yes. The key is reducing the likelihood of false positives.
Yeah. And so it says false if any of them are 0, and it says true if they're all true. So it ands them together. So does that make sense?
made sense to me. Hopefully it made sense to someone that's watching.
Yep. And so we're gonna code one of these up real good.
All right, let's get started.
So I've actually successfully implemented these in JavaScript, excuse me, and in C#. I do have a reference implementation ready to go if I get stuck, but there's really not. They're actually fairly simple to implement. I'm curious what this is going to look like to test drive.
Yes, exactly. All right.
Because just like the hash table on the linked list, I mean, we could have made the linked list, just backed it with an array, and all of our tests would have passed. And so we need something that does a little more than that. So, yes, we got the Bloom filter spec, and then you want to.
I'm going to steal the beginnings of this one.
Yeah. See, yeah. And
that should be the right number of curlies.
Yeah, but you need closing parents too. There you go.
Thank you.
Right, and then so we aren't making a hash table. We are making a Bloom filter.
Okay.
By the way, the reason it's called a Bloom filter is because the guy who created it, his name was Bloom. His last name was Bloom, and you had gotten there already. So we need to create one, and I guess we're going to say what?
Do we want to say the size of specify the capacity of the array?
Yeah, well, we need to do both, because we need to say how wide is the bit array, and we also need to say how many hashing functions we're going to use. So we have two parameters to instantiate to create this thing. There is a formula for figuring out how many you need. For say, hey, I want to reliably have 1,000 items with 1% error rate, but I don't understand it well enough to do it in JavaScript. And so I think we should just go with the more hard.
Let's just put in a number, because I don't think we're super worried about making sure that it has, really, that it's really efficient about not having errors.
Well, I feel like we should have the loop for the hash function, because very, very rarely are you going to use only one on a Bloom filter, because that does guard against those collisions very quick. I mean, that's the point of them. So I think if we want to pass into the Bloom filter the
capacity and number of
the number, the bit width, and then we'll say 1024, and then the number of hashes, let's say 5. Okay. The thing I don't like about this already is that I don't know which number is which. You know what I mean? It's one of those things where it's like, well, we're just putting two arguments in and they don't mean anything.
While I agree with you, in this case, if we knew what the two arguments were, Guy, and you mixed these up, I would be really concerned about you. Because if you think that we're going to have a capacity of 5 in the array and we're going to do 1024 hashes, I think we might have done something wrong.
That's very possible. My inclination, though, is to want to use an object.
Yes, we could do an object with and actually name it. Yes,
it's called the bit width.
Yep, I'm good with that. Yep,
and then hash count.
Yeah, that's basically what this is, S&B.
What's that?
He said to use a tuple with named items, and that's basically what like all objects are in JavaScript, because you just make them out of nowhere, so they might as well be a tuple at that point.
Yeah, and then that way, if they're missing, we can probably give them meaningful defaults and stuff. And then
starts out empty. Looks right to me.
But we don't know that it's empty. Because we have no way of reading it. The external interface is we can add things and we can check for things.
I think I'm going to allow an empty, which is it returns all falses.
Well, how would it return all falses?
We could, I mean, like for the implementation of is empty, we could check the underlying array and just confirm that everything in the array is false.
Okay, okay, we can do that.
Yeah, we're putting an interface on this thing. If we want to do that and put this on the interface just to help us test it, I'm cool with that existing.
Yeah, I am too. Okay.
Yep.
Then we could probably make sure that the underlying bit array is the right size as well.
Yep.
So when created, so our first test is going to be it has a bit array that is of requested size width. That sound like a good test?
Oh yeah, that's fine. Yeah.
Expect subject dot.
How do so you're thinking like is it exposing it in some way so you can tell that there's. I guess we could check the underlying thing and just make sure it's right. Yeah, I'm fine with that. Yeah.
That was where I was going.
Yep. Yeah, that's cool. Yeah.
2b 1000 2 equal.
Yeah, to equal 1024.
Yeah.
Yep.
And then we can do the same thing for the and we can check then that the bit array is of the expected all falseness. And actually, if we're going to be using a linked list under this, which we were,
I think you've convinced me to do the array.
Okay.
Because it'll be a little easier.
If we use our linked list, the creation would have to then create, go through and loop to create all the entries into the linked list.
Yeah.
Which would be kind of fun and ridiculous, but and it would definitely be inefficient.
Yeah, it would be inefficient. Yeah, so just to clarify, our intention isn't actually inefficiency. We were joking about that. The intention is just to build it so that it's interesting and fun and you can see how it works. It happens that if you do it that way on a stream, you're going to end up with a very simple and thus inefficient structure.
Yeah.
Okay. So what went wrong? Bloom filter is not a constructor. Looks like we didn't actually make it. All right, so that is failing for the right reason. Do you want to make it or should I?
Go ahead. We sort of both coded the test, but
that's fine. It doesn't matter.
Yeah.
So we want to make bloom filter.js, and we're gonna export that at the bottom, which I'm just gonna save there for a second. I want to grab this because I know we're gonna need it. So while I'm jumping between files, I'm gonna do that. And were we gonna use the linked list?
No, I think using arrays.
Okay.
I think using a linked list will confuse everyone on how this works.
Okay. Yeah, our linked list wasn't bad. Let me steal that so I don't typo it then, and we'll close those. Here it is. Dunk. Okay, module, export that, and now we're going to make a class called bloom filter. And
2 spaces. Yeah.
Yeah, I know. I was doing it.
Yeah. Well,
it's called constructor in here, right? It's been a while. It's been since our last one that I did. One of these.
And we need to do this too.
Oh, yeah, sorry. Did I might have typed that.
I'm not sure, but it's been done now.
What did you call, because we need to look at it, it is bit array.
Yeah.
Bit array equals that.
Yeah.
And in our constructor, you gave me some kind of arguments, and we set the length of that. So we'll put in args.
Actually, we can do destructuring. Well, I'll wait for refactoring.
Yeah. That's fine. Do they do it like this in the JS?
We'll need to say this bit array equals new array, and then the width.
Array length. Args dot bit width.
Yeah.
Okay. And you wanted us to keep going with the no semicolons, I assume. And
yeah,
I'm just going to leave this commented out right now. And we'll comment that in as soon as we need it, because we know we're going to need it.
Yeah. And
did I get enough for this? Bloom filter's not a constructor. Module export. Oh, I didn't include it over here.
We didn't require it.
Wait. Yes, I did.
Yeah. Oh, well, we need to put it in the data structures.js at the root.
Oh, yeah, you're right. There we go. Bloom filter. Bloom filter. Okay. Yay!
Huzzah! Passes. Okay, so the refactor I want to do. Are we following me?
I will pin to you. We're on you. You're gonna just put in the object there.
So we can destructure that. And so that says, hey, if you pass me an object in, pull out the field out of that and then assign it to that variable name. So then we can just do this.
Yeah. So when S&B was asking for us to do that with a named tuple, it's like, yeah, that's basically what JavaScript does. Like, that's their objects.
And that should still work. Let me see.
And it does.
It's all green.
Excellent.
Cool. And I think we can even go so far as to do like 64 like that, and provide default value if it's not in there.
Nice. Which means since it didn't just fail, that means that didn't override. You don't want to leave it as 64?
Well, I would want to have a test to drive that behavior in. All
right. So
I refactored. I think it's your turn to write a test now.
Yeah, I think so too.
Oh, you already are. I'm not following you for some reason. Live share.
All right. So let's see. So when created has we'll say no known values. What would you describe as because I want to describe the state that everything would be false. Because I was thinking that it would know about the existence of. So contains no values.
Well, I think what we're really saying is it has a bit array that's full of falsehood or something like, I don't know.
Falses?
Yeah, full of falses or a bit array of falses. That sounds good.
Should I check for explicit false? I'm thinking yes, and not just falsiness, but we could go either way. So we'll force this to be explicitly false and not treat like undefined array values as false.
Yeah.
Cool.
And so yeah.
What do we want to put on that instead of? Do they have an all?
I don't know. I'll take a look.
Seems to imply they do.
Well, it may not do what you think, though.
That's true.
I'm on the site right now.
Cool. Let me know what you find.
So it's you can expect it to have all keys. I wonder if there's a dot only. No.
JavaScript.
Hey, I'm looking at the Chai assertion library here. There's actually a lot of powerful assertions in Chai. But there's a members.
Hey, thanks, Ardalis. Please cite Steve. Steve, this is embarrassing. Your site's slow.
So we could check it to not have members false. But I would rather explicitly check that they're all true. That's a better test.
Yeah, I was going to check that they're all false.
Or I mean, not. Yeah, I said that backwards. We could check that it doesn't have any true members. But that doesn't mean that they're all false. They could also be other things. And so I think we just need to loop through it and check that they're all false. I think that's probably the best way to do it. I'm not seeing a way to do that.
jQuery is function. What is this? And welcome, Echo Strike. Thanks for that tier 1 sub.
Graybeard level over 9,000.
Yeah,
it's definitely gray. See, the way you get a gray beard like this is that you just grow it and then you get old. And
Do they
that's
have
the
an
secret.
any?
They do, but it doesn't do. So we can.
There's filter.
I see. Yeah, on arrays themselves, there is an each, or not an each. There's a
There's
an
filter
every,
though.
or all, or what is it now? I can't remember now.
Yeah.
There's a sum and an every, as I'm pretty sure what it is. Java script MDM array. I always have to bring this up because I can't remember which array functions are available.
Okay, so filter to that dot length to equal 0.
Okay, let me take a look at what you're doing here. Yeah, so you can do every, and then that will turn true if that statement is true.
Okay, so it is every. Hey, there you go. There's that's the one I was looking for.
And then we don't even and we do want it to be, we want triple equals true because we want explicitly to be true.
Yes.
And then but that will
actually for this we want everyone
false.
to be false. On this one, we want everyone to be false.
To be true.
Which is silly, but yes.
Yeah.
Like that, right?
Yes.
Does it want a method?
Nope, it doesn't actually require parentheses, which is a little weird.
That is weird. Thanks, Chai.
Okay.
Okay.
And then, and I believe
so
there's
I can't believe that passed.
Oh yeah, it did, didn't it? That's wrong.
Wow. This is shocking.
No, that can't be right. Because when you do a new array,
I expected them to be undefined.
It's going to be full of undefineds, yeah.
Yeah.
That cannot be correct. So for every x, validate that x is triple equal to false. Let's try this. I just want to see if I'm smoking crack here or not.
And yeah, because I guess if that were not correct in some way.
And it still passes. That is
shocking.
Oh, I know what's going on.
What
so just because we said we wanted an array of a particular size doesn't mean there's actually any elements to walk over.
Oh, so, yeah, the length was, but
yeah, you need quadruple equals, yeah.
Thanks, S&B.
Yeah.
JavaScript.
Well, it is defined, so to be defined won't help us here.
Yeah.
I wonder if my nope, it doesn't. I use the Fira code font, and so when I get a triple equals, I get 3 vertical lines that are 3 characters wide, or 3 horizontal lines, and so I was like, we'll do a quadruple. Can I do a quadruple equal?
Yeah.
But yeah, but so that's the problem. So the real question here is, how do we write a good test for that? Because this test is clearly then deficient, right?
Well, the other way that we could do it is we could for each over all the items in the array, right?
Well, we couldn't for each because for each is going to have the same problem.
I guess we could do a for loop on it.
And so we'd have to do a for loop, which is hideous.
Hey, don't give me that. It's not hideous.
It's old school.
There you go. Look. Let I equals that, and then it's subject dot bit array dot length. Because we checked that the length was right.
Yeah.
And so we don't need the element thingy. We just need to throw if well, I guess we could just expect that each one is correct. I'm pinned to you. That was jumping me around there for a second. Yeah. And then we could expect that each one. How did that get there? Subject dot bit array I
To be true. Or to be false.
like that.
Not as old school as GoTo.
That is not as old as GoTo. GoTo is much older than 4.
GoTo's how you used to do loops.
Yes, it's how you did 4 before 4. Oh, okay, yeah. Not as old school as GoTo. Yes. Yeah. There we go. Expected undefined to be false. Exactly as we wanted. There we go.
You know, technically, and I'm not going to advocate for this, but...
Don't make me come over there, Guy. Don't make me come over
not
there.
Clear. This is one scenario where that would help, right?
Yes. Don't make me come over there.
Hey, I'm like 120 miles away. I'm good.
100. You are about 120 miles away. That's a fair guess.
Yeah.
Could be further. I don't know exactly where you are in that area.
I'm on the northeast side.
Oh, then yeah, probably only that far then. Yeah.
Yeah, and I used to drive up, not to specifically where you're at, but up in your neck of the woods because my wife went to Kent State. So
yeah. Okay. Okay.
So I need to make
fails. That's you now. I made the for loop.
Yeah.
when our previous test didn't fail right.
Yeah. It looks like there might be an array.of. Is this new? Oh, no, that's not what I want. Okay.
Whoops. Sorry, everyone.
So I was looking at array.of, but in array.of, you just give it like 4 arguments, and then it makes a 4-dimensional an array that's got 4 elements. I want to do array.fill.
Yep, there's something like that.
Yeah. Fill. False. That should make this pass. So that'll create a array of our bit width and then fill it full of falses. And that passes. And so just to prove that that's well, we got to do one other thing because it probably works with true, but there's this thing with fill where if you like fill it with an object, it fills it with all the same instances of the object. Like if I do fill like this, it's all the same. It's all the same foo.
Yes.
Which is annoying.
Is that the case when you do like false and true though?
I don't. We're gonna find out.
We will find out very quickly. That's what the tests are for.
Yeah, but the fill will cause it to have values, and now there should be 1024 values in it. And one of the things you can do to solve that problem is if you map it, and then you can map it to an actual distinct value, and then that returns a new one each time. So if that doesn't work, that's our fallback.
Yep.
So
all right. We could also just use gotos to solve it.
Gotos, no, it's my go-to solution.
Yeah. Womp, womp, womp. All right, give me a failed test.
Okay.
Gimme.
Okay, so it has a bit array of falses. We need to.
I think we're ready to add an item.
No, I think we want to check the hash count.
Check the hash count.
Yeah, we want to check that we have the right number of hashes.
Oh yeah. We could absolutely do that first.
Has a hash array of requested size, requested count. Hash. We'll just call it hashes. You want to call it the hash array? Yeah, it's consistent with bit array, right?
One's like the underlying structure. I'd be good either way on this. I'd probably lean hashes, but yeah, hash array's fine.
Yeah. I'm not normally a fan of calling it the thing. with array at the end of it. But
The only reason I like it
hashing,
for this one is because I wanted to make clear what the underlying data structure is that we're using here, because I
yeah,
think it's very relevant. Whereas how we stored the hashes
is less
really wouldn't
relevant.
matter because you're not going to exceed like, a dozen of them or something, right? So it's
Well, we
not
could
like
call
there's
the bit
some
array bits, but then that just,
that get
that could
confusing.
mean a million different things, right?
Yes.
Little
All right.
bits. Uh,
Yes. All right. So we're going to do that. So you set that equal to 5, which is correct. And when we run this, let me guess, hash array doesn't exist.
yeah.
Yeah, couldn't read length of undefined because hash array was undefined. Excellent. I will make hash array. I don't have an easy way to do this, so I'm going to do that. Okay. What was that value called? Hash count. Hash count. Hash count. And
We don't need to fill yet.
I don't need to fill it.
Cool. I have no refactor. I mean, we could check the type of thing that's in there, but I don't think we want to. I don't know if I want to do that yet or
I'm
not.
not worried about that yet. We're gonna want to use them eventually, but I don't want to dive too far into just checking all the implementation pieces of this.
Yeah, yeah.
So how about I really want to shove something into this because I think that's going to make us actually start to have to implement some of this.
Yeah, yeah.
Do we want to
So,
try? Do we want to write a thing first that says it returns false when you try to get one that's not there?
yeah, I
And
think we
then
should have that
I
as
think
a
we'll do
test.
that first. That way, when we do true, we can then check that it's there instead of just returning true for all of them.
Yeah. So, we've created created it, and then so
Yeah.
what's our next test? It'd be
Well, I think this is going to be the test that passes, sadly.
no,
Because
yeah, probably will.
yeah, I think it's going to, which is fine. Um, it's just when a test like this passes, you need to then very quickly either make it fail intentionally or get the one that pairs with it to prove that there's a difference.
Yeah.
Okay, so when created,
I think this is probably it is empty, or it.
well, we sort of checked that with the has a bit
Yeah.
array of falses. Returns false. Do we want to say false?
Well, we could say it does not contain.
Does not contain.
It does not have members. Have any members, or maybe it doesn't have. Although we really can't know that definitively at this point.
We'll say does not have sample members.
There we go. And then so the method probably be like subject dot has member, and then pass it a string.
Has member? Yeah, I like that.
And then what's our theme here?
Well, Guy, you got to remember, we're checking to see whether people are members. So we're looking to see if they're on the list, right?
Okay.
So who is not going to be on the list? We need someone that's not cool. So Doug Butabi, is that how you spell Butabi?
I don't know who Doug Butabi is.
Well, we could also check for his brother, Steve. And we're going to say that both of these are supposed to be false.
Okay.
Your brothers? No. Yes. Oh, man. I hope someone got that joke. I hope someone in the chat gets the joke. And welcome, Cyrilash and Fuel Snable. Welcome to the stream, everybody. Glad to see you're here. They are the characters from Night at the Roxbury that can't get into the club because their name's not on the list.
Oh, I didn't know their
But
character names.
I probably... Oh, I spelled it right! Wow! I just had to Google to find out if I spelled the name right. I got their names right. That was good. I win.
So who gets into the club?
Richard Grieco.
Yeah. So because do we want to check to see if they're not in there and then add them and then say no, they are in the club? I guess
Well, they do eventually get in with Richard Grieco. So we're in the next test. We're going to have to add those three and make sure that they get in.
Sounds good to me.
Yeah, there we go.
Okay, so let's see if this fails. It should, because as a member doesn't exist.
Yeah, that should absolutely fail. If that doesn't, yep.
Okay.
All right, let me pin to you and we'll watch.
As member.
Haha, you have to write real code that does things. It isn't just in a constructor. You're just going to return false?
Yeah.
Of course you are.
In this instance, this is the appropriate thing to do.
It really is, yes.
So I haven't written any real code yet. Well, and we, I mean, we're going to need to, we need to hash those strings in order to return them. And then there's a lot of stuff that'll flow out of this immediately, right? As soon as we do the next test and say these need to be true, then we need to hash the strings, but we're going to need tests to validate that we're actually hashing the right number of times and the right number of bits are set. Actually, that'd be it. It's like when we hash a string, it sets a number of bits equal to the hash count. That's an interesting test. So, it's my turn to write a test, isn't it?
Yes, it is. Let's go make one. That forces me to actually do something. I am sorry, Cyril-Ash, I have the bot turned off. So there will be no bot defenses. It was doing weird stuff and I didn't want to debug it.
I love it when I misspell function in a slightly inappropriate way.
Function isn't inappropriate. Functions are fun.
So we're in the context where do I want a context here?
I think so. I think we want to do when we added when we've added something.
A member. And when we add a member.
Yeah. Now the sad part is the our before each is going to fail here.
Yeah, that's kind of. We could add you can add members, but that feels kind of lame. Subject.
Just put Richard Grieco in. Can you spell Richard Grieco?
How is Grieco spelled?
I don't know. I'd guess
it's probably not like this, right?
No, but you could probably do that. I don't know. Is it like this? Would be my guess. Okay. But I could be way off. I'm not. Oh yes. That's 3 for 3 today on spelling names. I win.
You are winning the internet today, aren't you?
Yes, exactly. That is success right there.
So when we add it, it sets a number of bits in the bit array equal to the number of hashes. That is a wordy test.
That is. So
I can't think of a better way.
When we add a member,
there we go.
Sets a number of bits in.
in the bit array to true equal to the number of hashes. Does that make sense to you?
Yes.
I don't really like
Are
it.
we are we that worried about getting that specific on this test? Maybe we should simplify this test and then do that check as a separate piece.
Okay, so yeah, it does feel like maybe this might be doing two things.
Yeah,
Or
that's what I
doing
was thinking.
How would you recommend to pull it down? Can we just check to say if we add a member, we can get a member?
Let's see if we can confirm he's in there.
Yeah, the problem is that does all of the things that.
True.
that
Yeah. No, because all I'm going to do is just say if Richard Greek. When you say get member, that's
you're going to not use it, right?
I'm not going to use it. I'm not. So don't worry about that yet. We'll have time.
Okay.
I think we'll have time to slowly implement it.
When we add a member, the member is probably there. Right, because it's a probabilistic data structure. We're not guaranteed that they're there, right?
Well, no. We are guaranteed that they're probably there. So if we've put them in there, we are not going to get a false.
That's true.
Which means that we know this is going to return back the correct value. What we don't know is that it's returning the correct value for the right reason.
Right. Because you could Steve Butabi could have the exact same values that go into the bit array, and then all of a sudden there's a collision, and they're there.
Which is why, as soon as we've done this part, this context, we suddenly cannot do this exact test anymore.
Right. Which is why we put them down in a separate context.
Correct. Because as soon as we've added even one, it is possible for that, given the hash function, to collide with those.
Yeah.
Okay. So the member's probably there.
Because I think it's funny.
All right. So we want to do. So you want to do an expect on this? Expect.
Yeah.
I'm helping.
I'm helping. To be true.
Yep. And it has to be. You could almost change has member to be like probably has member.
Yeah. Well, what we should do is instead of returning true, we should return something in JavaScript that's truthy.
No, that is not a good idea. No.
Probably true. And so you create a Bloom filter that returns false as specifically a false value, and then returns a value that's truthy. I mean, come on, that is kind of funny though.
Oh, I agree. Okay. So the member is probably there. Let's see. This is gonna fail, right?
It does indeed fail.
Because we didn't even do add member yet.
Yeah.
All right. So add member. Text value. Value. What do we want to do with it?
No, you can't call that .has member.
Why not?
Because they have a function on line 10 called has member. Then they'll collide.
But their method in the will it? Okay.
Yeah. Because remember, JavaScript classes just create objects that are value pairs, right? You called add member has been called.
Has items.
Has items. There we go. And then
thus dot. Did I set one wrong?
No, I was just getting rid of semicolons.
That's a good point. I don't need that.
The pass? It does
Yes,
pass.
it did.
Okay.
That is awful cheating right there that I just did.
That is
Awful
awful cheating.
Return.
You see what I
Oh
have to
man,
work with there?
Cadmus wins. Might has member returns does not 0.
Yeah.
Oh, I think Cyrilash missed my joke. Ralph Wiggum also says, like, me fail English? That's impossible.
Yeah.
And that was my joke. So me, Ralph Wiggum, that's impossible. That was yeah. Okay, so I need to give Guy a failing test that actually forces him to really check that one. Do we dare with a false version of this?
I mean, in theory, you could make a Bloom filter with a bit width of 1 and 1 hash function, and then it just basically it just becomes a Boolean, right?
Yeah, it's like have you put a value in? Yes, that's we're already
it's like,
done
is
with
that in there? No, it's not in there. Have you added
that's
anything?
actually
Yes.
Guy, that's what I just built.
Yeah.
Instead of an array, I just had one bit. It's a Bloom filter. Done. Did you put a value in? Yes, you did. That is technically a Bloom filter. I just skipped the hashing functions. Okay. So what else is there after you've put one in?
I think we do need to actually check the bit array. In this
Okay,
case,
so
say
here we'll say
it has modified the bit array. The bit array has something.
Bit
true.
array has
truth.
Has some true values. Does that sound good?
Yeah, that's kind of what I was thinking. That's a little simpler than saying it has a specific number of true values.
Yes.
Which I think is a thing we'll want to do next.
Subject bit array. We can, yeah.
And we can actually do the.
What did we do for the other one?
Well, we did the for loop initially, but after that we don't.
Yeah, we don't need that because we should have an item in there.
Well, and
what did we do before? Was it like every?
Yeah, every. We in this case we don't want every. We want some as an SOM.
Oh yeah, that's a.
Some of them should be true.
How many of these do we want?
All of them.
Just kidding. After a discussion of needing 4 of them, I figured, why not add like 8? So we're expecting some for the value to equal true to be true.
Yeah. So if none of them are true, then this should resolve to false, which is what will happen right now. So this test should fail.
Correct. Did it fail for the right reason?
I can't tell.
There it is. Okay, so
I can see Brendan's terminal, but it's always
kind of wonky.
It's disjointed and wonky.
All right, Guy. I am pinned to you. Let's go.
Woo! Okay, so has member
real code.
This dot has items. Add members. This dot has items equals true.
After those last 2 data structures, I am really glad that whatever order we started with this time has you having to write the real code this time. I remember last time I was like both of them, like, God, how did I get stuck writing the real code? They were like a couple of the big jumps that I was like, what? No, I didn't dodge it. Okay. All right, so you're going to check just the initial bit value, which totally works. So our hashing function is 0. We replace whatever value you gave us with 0.
Well, exactly.
Hashing function, Guy. It's like my random number generator. 9.
That's right. 9.
9.
Do you have a random number generator? 9. Bad German joke.
Okay, so it does pass. Looks like we both ran it.
Yep.
And so now you need to give me a failing test.
Yes, I do.
Have fun, Cadmus. Yeah, the best jokes are the ones that have to be explained, Fuel Snable. They really are. Thankfully, anyone that got my joke originally got it and just thought it was funny and didn't require the explanation, because it was impossible. The bit array has the correct number of true values. That's that. I'm okay with that. Yeah.
And then, so to test this, we need to, I'd say, filter where it's equal to true.
And then check the length.
Yeah.
Okay. So we're not checking that they're in the correct place, but we're just making sure, yes, it's set the... you set it to 5, I think. Yep.
Yeah, I was just double checking that.
Yep,
I
5.
feel like that's a magic number that we should probably pull out.
Absolutely can.
For our tests.
Yep,
so
I'm
just going to put it right here.
Sounds great.
Bit width equals 1024. Const hash count equals 5.
Now you can see, everyone, the wild old developer is putting in this ancient naming convention with caps and underscores between them.
Yeah, it really is kind of old, isn't it?
I was just kidding. I do the same thing, actually. It really is an old convention.
It is. Let's see if this fails for the expected reason.
Some of us see caps like that and know exactly what it means. Yep. Okay. So, because all we did was set the 0. So okay. So let's do some actual hashing then. Thanks for shoving this on me. That's great.
But actually, it might be a good time to we said the hash counts. The hash array was the right size.
Cough, cough, cough.
It might be a good time to.
Just kidding.
Sorry, I just had two thoughts impact on my brain at the same time. One of the there's a flaw with the test I wrote, actually.
What's the?
Well,
that two of them could collide, you mean?
Yeah, even though we have 5 different seeded hash functions, they could still get the same index. So even,
exactly, that's what I mean. Yes, they could. So it should be. I'd say we could probably go with the probability of you only putting it in one slot to be super low.
Yeah.
So I would say
it's worth noting, though, that this is not, strictly speaking, a perfect test.
Yeah. So if we wanted to, we could tweak it, though, to say that it's not more than 5. Say that it's less than or equal to 5 and greater than 1.
Yeah, I think there's actually to be at least or something like that in Xenon or in.
Okay. I'm pinned to you if you want to tweak the test to that before I adjust it. Flaw is another word for feature, Echo Strike. That's right.
Yeah.
So down here, line 52, Guy.
Yeah, I'm looking up the.
Oh, you're looking in the.
Should be at least 1 and at most 5. We can probably just get away with. And actually, I think we can do that as 2. Now let me double check here again. I'm sorry, I'm looking at the specs.
I can bring it up too.
Here we go. Even better. I can make this test even better.
Can it be between?
Now I could do this. To have length of at least 1 and at most 5, which would be hash count.
And I think we can leave the 1
as well.
There.
What's that?
I think we can leave the 1 as a hard-coded value in there and not worry about that.
Yeah.
Because 1's a very special number. And
it looks like there's not a dot between.
Okay, so, well, that's fine. At least this, at most that, definitely.
And I think this will work. And I'm just going to pull that down so that it's on one. I can't see it on. It's sideways scrolling for me. Probably is for you
Yeah.
too. Yeah, it is.
Yep, I had barely fit it on the screen, but yes, this fits it much better. All right, let's go ahead and run it. Unless you already did. Hey, it's passing. Because it did set one. We want at least we want at least two. And this requires that the hash count is greater than 1.
Yeah. Yeah, I think we may have this reduces the odds of it being wrong. In theory, you could have.
That's what I was saying, is like the probability with us doing 5 of only having 1 is so small.
Especially
I'm
with
not
a
gonna worry about it.
1024 with a bit array width.
That's kind of what I was thinking. Like,
Yeah, I know.
it's small enough that I'm really not worried about it. Okay.
Yeah. This is like testing random number generators, right?
Basically, yes. That sort of is what we're stuck with there, in order to make sure that that's right. Okay. So we want to add a member. So you got to help me with this one a little bit because I don't remember. So we want to bring in murmur hash again, right? And I don't remember how that one works. So let's do it.
We can
our
look
hash
at
table.
the hash table. We got murmur hash in,
Where
and
did we
then
hash? Okay, so okay, I'm gonna grab that, which I'm just gonna leave that code there for a second for myself
yeah.
in the future. And how did we set our seed? Oh, and I should make sure I actually, I'm gonna steal that whole line to remind myself.
Yeah.
And we set our seed like this.
Yes.
What's wrong?
No, nothing. We're good.
Okay. So we have a. Do we need to seed each one separately then?
Yeah. So we need 5.
So we'll need 5 seeds. We'll need a seed per hash count.
Right.
Do we want? So is the hash array just going to store the seeds?
It could. When I created it, I sort of had an implementation in mind, which is probably a bad thing. Because I was imagining the hash array being an array of functions.
Exactly, but I don't know whether we need that. Do
we? It's one way to do it, but I think the.
So
I think
if we were doing that, that gives us the, because that would give us the ability to have them actually use different types of hashing for each one, which could make a difference, but I don't think we really need it considering how simple our structure is.
Yeah. Well, and the last time I implemented this, what I ended up doing was like the hash array was an array of functions that's then called the murmur.v3 with a particular seed. And so the hash array started out as an array of I filled it with calls to murmur.v3. Well, I filled it with a random seed generation, or mapped it, I think. Oh yeah, here's what I did the last time I did this. Is I filled it with this. And then I mapped that
exactly
to this call here.
Yep. That's what I was about to do.
Yeah. Okay.
I was going to set it to 0 instead of, max safe integer, but yeah, that's fine.
And then and that doesn't quite work the way we've done that.
Why doesn't that work?
Well, because the map needs to take a function.
Oh, yes. Whoops. Like that.
And then x is going to be the max safe integer, so it'd be math.floor times math.random times x, like that.
I guess you can. Yes, you can. We don't really. It's a constant all the same, but yes, we could use it that way if you want.
Well, that's just that was how I'd done it before.
Okay.
And then I map, and that gives us
That should give us a set of
seeds.
seeds. Yes, exactly.
And then what I did with next was I mapped it to a function that returned functions that call murmur v3 with the seed.
Hash array. Yeah, I'm not going to do that though.
Yeah.
That's the advantage of me getting to write this part of the code.
Yeah.
So we're going to say seed, and we're going to do... actually, this is going to give us our indexes, isn't it?
Yeah, so we probably want to do a
So
map.
we're going to map it, because this is going to get us our indices, and I'm going to toss that in there. Okay, so we're going to take our set of seeds, we're going to map it, we're going to put seed as the name, and then we are going to make this be seed. So we're going to say, get us our murmur hash of the, I guess that's key now, or I could rename it. We'll do value. So instead of key, we'll say value. So we're going to say hash the value using the seed from our hash map. And we don't have a capacity, but we do have this dot bit array dot length.
Yeah.
Which should also get it. Yes, Echo Strike, you should be drinking Mountain Dew while you watch this. That is highly important.
I'm drinking caffeine-free Coke Zero, so that's not very extreme at all.
I'm drinking Coke Zero. Mine has caffeine. Someone's gonna shoot me for this. For each, and this will be hash. Can I? Oh, what did this get me? This got me so we modded down to the length of the array, and then we're gonna say this dot bit array of the we'll say
technically
I
that's
guess
really
this can be index.
Yeah.
I was gonna say hashed index, but I'm like, at that point it doesn't matter, it's just the index. So set that equal to true.
Yeah.
At each one of those spots, and then that should do it. Let's check that test. This is still not right. I made that one fail, but let's have the test tell us that.
Yeah. So there's a question I saw. How does add member not fail when passing in a value to a function that does not receive anything?
That's JavaScript, Cyrilash. So I did not have.
Yeah.
So in JavaScript, you can define the parameters that a function accepts, and you don't have to pass them as the caller, and it'll just be undefined. All of them are optional. So you don't know what arguments you're getting inside of the method. And then the other crazy part is, so you can give parameters. You can give arguments that the function doesn't have any parameters defined for. So like you're like, yep, here, have these values, and it'll be like, cool, whatever, yeah, sure, you did a thing. And then additionally, it can have parameters that you didn't even pass. So you don't even have to give it the ones it asks for. JavaScript's weird.
Yeah, it just it basically, if you pass it 10 arguments and then say I only care about the first 3, then it only accepts the first 3. The rest are passed in, but they're ignored. If you ask for more than are passed in, then they just become undefined.
I like Sarah Lash's question. It's like, yep, JavaScript is weird. You like
why do you use JavaScript again?
Okay.
I haven't answered that question actually. I have a good answer to that question. Because of the browser.
Okay.
But in the browser, we had the alternative. In the 90s, there were the wars about which scripting language was going to be in the browser, and VB script could have won.
Okay, so
I'm grateful for JavaScript because it means I'm not doing VB script today.
Whoops. All right, so I am going to do this horrible awfulness that you're going to murder me for. Return we're saying every. So that's going to do the hashing of the
Yep.
value, which we're going to want to extract because we're definitely making some duplication there. We're
Yep.
going to say that every one of these triple equals true.
Yes.
Man, are those methods ridiculously similar right now when you see that.
They
Like, wow.
really are.
Let's see if that works, though. Oh, value's undefined. I forgot to put it in there. There it was. I was the guy that nuked it because I was like, we don't need that. We'll put it in later when we actually need it. Because it was funny because in our test, we called it passing the value, and I was like, we're not checking that yet. I'm just returning true.
Yeah. Okay.
See, I was the one that finally got bitten by that. Okay, so it does pass now, which is great.
Okay. I'm obviously going to refactor here.
Yeah, go for it. Go for it. Yeah, I will pin to you.
Because
Let's start some refactoring.
Yeah. Because the hashing that we're doing here, this bit here.
Just for the record, JavaScript is the Taco Bell of programming languages, I think is what Fuel Snable's going with that. It's kind of like Demolition Man, where Taco Bell was eventually the only restaurant that won the fast food wars. JavaScript is the language that's going to win the language wars.
For this generation, anyhow. JavaScript's the new Java. Java's the new COBOL. COBOL's still there.
Yeah.
So I'm trying to resist the urge to refactor this in a way that I want it to be, and refactor it instead. Try and find a way to refactor it in a way that reduces the duplication. Line 13 is clear duplication.
Why don't we just make a get hashes for now then?
Yeah, well, that was what was going to be get get indices or
get
compute. I don't like to use the word get because there's because I'm an old Java developer.
Make indexes.
And be
how's that?
Indices. Come on.
No, we're not. Don't make me flip this table. Wait a minute. I'm going to have to pick it up. Never mind.
Hey, who's doing the refactoring here?
I don't know. The chat's doing the refactoring.
Chat's doing the refactoring. Yeah.
Yeah. Hang on.
So we can do this here. That basically becomes this function here. Wait a minute. There we go.
And Martin, I agree. There are some very interesting languages that should become more popular. Yep. So yanking our code that is perfectly identical.
Yeah. So we can call make indices.
Yep.
Value.
Yep. And then we just need to call every on that. Yep. And that top one needs to return at the beginning. Yep. There you
go. Yeah. And so that should still work.
You know what would be an interesting thing to do that you could do in a Bloom filter? When you were setting the value, if you did something like this, if you just said you could do you could almost do like a has duplicates, like a has replicate, those kinds of things. The first time you got a collision where it was already true, and you could be like, if you did it, like if you have indices that were the same, like one that was, I don't know, there could be some metadata that you could do for things.
It's actually interesting you say this because Redis has a Bloom filter implementation, and it does that. Whenever you add a member, it returns true or false to indicate whether you've actually changed the state of the bit array or not.
Exactly. Yes. Because
that's where
while that does not necessarily tell you whether or not, like the exact state of what percentages of failures you're going to get, like it can give you some indication of like how overloaded this thing is, how likely you are to have false positives and other things, because I think the more values you had in there, the more likely you are to get false positives.
Yeah. Well, yeah, because as you go through this, you start setting more and more ones, and eventually it fills up,
Yes,
right? And
because
then it just lies to you all the time. So when a bloom
yes,
filter fills up, if you put more than you're supposed to in it,
yeah, because I
um,
was thinking like when you
it
add
becomes
members, you could say how many of those were already true. At which point, it's like if you ever came
yeah.
back with a 5, it's like this was either already in here or you were already going to think it was in here.
So it might be worthwhile to
But
check and
let's
see if the state of the bit array changed. I think I like the idea of adding that feature to add member, have add member report, hey, I actually added something, or nah, this collided, or something along those lines.
something to come back to. Let's get the other basic stuff in here first. Okay, so we have,
I
was there any other
actually think
refactoring you
we're
want to do
no, there's not.
on
I
this?
think we've completely implemented the bloom filter actually.
We don't have enough tests on that to confirm that. I don't think we've added one thing.
That's true. Um, but I know our implementation is done. It's saying it's dirty here too. There we go. Let's make sure it still
Uh,
passes.
all right, let's run it. Yeah.
There we go.
Okay, good.
So we
66
need some
passing. That
more.
sounds right.
We need some more
We need
tests.
some tests. Yeah. That's the funny thing is even if you're done, you sometimes know like I don't have enough tests to really confirm that it was done because occasionally you get in that spot where there wasn't a simple step, which is what we hit just at this point. There wasn't a simple like I guess maybe I could have been worse and been like, yeah, I set 5 of the you
Yeah.
might have noticed when I first did that I was like, yeah, I'm just going to set 5 of these, copy. Like
Yeah.
that would have been a
Um.
good way to force us to try it. But why don't we check and see that the other guys are not in the list
Yeah.
or something like that? With only one in a set that size, the likelihood of a false positive, I think, is very low.
Yeah. I actually wonder if there might be a way to spike the random number generator. So when we say math.random, does math.random in JavaScript have a seed value you can pass into it?
I'm sure it does.
Because if it does, then we can hard code the seed, and then that will
Uh,
guarantee that we don't have
this
any.
claims it
That will make
doesn't.
our test deterministic, right?
Yes, because the way that when we test it, hey, yeah, that set of values worked. It would work every time.
Yeah. Well, let's find out if math.random has a um, math.random JavaScript. It may not. It may not have that capability. Um, um, it looks like it doesn't. Um,
Well,
it says the
that's fine.
implementation selects the initial seed to the random number generation algorithm. It cannot be chosen or reset by the user.
I guess they wanted to make sure the developers didn't do anything stupid.
Like we're about to do.
Well, doing it, yeah. I was gonna
So
say, like,
you
if
know what
you,
this means. On the next stream, we need to write a random number generator in JavaScript so that we can
well,
fix
folks, I
this.
want to thank Guy Royse for being on the stream. This was probably his last time here, but it has been great having him. And we were kidding, by the way.
Oh, good. That's good to know. Yeah.
Yeah. No,
So I think we're just going to have to do the unfortunate thing of saying, well,
good news,
let's just
everyone. We have time
yeah,
to
let's
work
just
on the binary heap.
yeah. uh, we'll have to do the thing with this test to these tests. We'll just have to have a little bit of a prayer factor in them, right? Because we don't know how the random number is going to be seeded for these hash arrays. So in theory, these tests could fail. However, it's highly, highly unlikely.
In practice, it's unlikely considering that we're setting
Yeah.
5 values in an array of 1024 that would
Yeah.
have to all 5 line up.
Yeah. So I
5
think we're
randomly
okay.
seeded hashes have to line up between those values.
Or we get a random integer that's the same value for 2 seeds. That could happen too.
Okay.
But anyhow, so let's just pretend like this is deterministic.
And just
This is just sort of the joy of test driving probabilistic things, right?
yeah, exactly. All right. So if we put this in here, for example, I'm not too worried about the fact that I think it's your turn. We're gonna say
Yeah, I've lost track.
does not have um uh, non-added. I don't know, unadded.
Uninvited. um, um, uninvited losers. Yeah. Well, it definitely does not have, because when we added Richard Grieco, he was probably there. So now it definitely does not have.
And actually, now that I think about it, that list analogy really does work out well, because was Richard Grieco really on that list? I don't know. Maybe he probably was, because he seemed to know the people there, but they might have let him in anyway. So like they probably didn't look. They probably just said, yeah, he's probably on the list, and let him in.
That's actually, as it turns out, one of the things you can do with Bloom filters. It's like, well, is the error rate acceptable? It's like you could like load all your usernames. Like, so you got like say your Facebook,
Yeah.
and you need to figure out whether someone's unique URL bit was taken or not. You can put it on a Bloom filter and say, is this in there? And if the Bloom filter says it's taken, even if it says it's taken when it's not, you just don't let them use it. And the damage of the false positive is not a big deal.
Okay, there we go.
Okay.
So they still are not allowed in. So the next option is when Richard Grieco rear ends them, then they're added to the list and they can get in.
We probably should have a scenario where we add multiple things to the list.
I agree. Yes, I was just making a joke that we would do the full like movie story. Okay, so that test already passes, but do we want to just put another context here, or do we want to put a context beside it?
I was just going to do that.
Okay, actually. Yep. And then a close curly there. Yep.
We add
excellent.
More members.
So now we're going to add them.
And then it's
probably has the newly added members.
Yeah. It's the newly added members are probably
there.
And the well, I kind of we'll get that test, and then we should probably verify that Richard's still there too, just to be.
Yeah, but I would do that as a separate test.
Yeah, yes, exactly.
There we go.
And we've got
whoops, we have something wonky with the braces here.
Yeah.
There we go. Excellent. Does that test pass? Yes, it does. So right now we're adding the tests that help to confirm that all of our code works. So at this point, we're not red-green refactoring. We are adding some additional tests that we think are going to help get us better coverage of this. And we are expecting all of these ones to pass because the simpler versions of them did. That being said, we could go disable any part of the code and immediately figure out which of these fail, and there are certain ones we would expect to fail.
The originally added member is probably still there.
That's a good way to check it. Yep. The problem is at this point, like once we start adding a few, it gets really dangerous to start saying things are missing.
Yeah.
Because then we're waiting for false positives.
I'm thinking that we should write a test to check the number of trues in the bit array.
We can, but it's hard to say how many there would be.
Well, I would honestly, I was thinking we might be able to do something similar to line 53 here.
Sure.
And then give it a range.
We can technically only guarantee that there's one.
What's that?
We can technically only guarantee that there's one.
Yeah.
Theoretically possible.
Now, if we change this test here on line 53,
okay,
of to have length of hash count, that's probably going to pass.
Most of the time, yeah.
Right. It's going to be different every time we run it, but it's reliably passing because we have 1,024 items. And we could probably do the same thing down here.
Hash count times 3. Except that one is
riskier.
Yes, that one is more likely to fail. How many times can we run it before it fails?
Well, seeing as how we got 1,024,
it's probably enough that it's going to be a rare occurrence if it happens, like a 1 in 1,000, 1 in a million chance.
Well, let's we can actually figure that out. There is a calculator for this purpose.
Because it's really because if you think about it, we should be making 15 trues in there. So it's how many can we shove in there before we get one collision? How many times can we put 15 values in an array?
So I'm going to paste a URL into the chat window here, or into the the editor.
Yeah, and I'll bring it up on screen.
This is a little calculator that you can bring up.
Okay.
And I've played with it a little bit. And so we want the number of bits. We've set it to 1,024. And we've done 5 hash functions. And if we...
number of items. Number of items, we have 3, right?
Well, what we can do is we can put... why is it saying that?
5 hash functions, number of bits in the filter. 1,024.
Yeah, so we got 1,024 bits in the filter. We got 5 hash functions, and we should be able to use those 2 values to predict our error rate. But we want 3 items in the filter, and we want
3 items.
Well, right now we have 3, so we can make something that safely can store, say, 100 items in the filter, right? And then we want the probability of false positives to be, let's say, 0.1%. Or if you do 0.1, that's going to be 10% probability. And then you can submit those, and it will calculate the rest of the math for you.
But I've got something wrong.
Yeah, so to get rid of the number at the bottom, I ran into the same problem. So get rid of M and K.
Wait, what is it? What? Empty these?
Yeah, so without K there, you can say I have 1,024 bits. We have 3 items. And then it calculates that out there, and then you see to have a 10% chance of a collision with 3 items, you would need 15 hash functions. Or no, you would need 15 bits and 3 hash functions. And that would give you a 10%.
Yeah,
so we have 1,020. We have 5 hash functions and 1,024 bits. And
so if we had 1,024 bits, the only way that we could get to anywhere near 1% is if we only had 1 near 10%, because it's actually saying, looking at this, that with only 1 hash function. So if I leave this empty, right, and I fill in that as 5, then our
yeah,
likelihood of having a collision is less than 1 in a billion.
yeah. 1 in 1,537,000,000.
Yeah.
Yeah, so it's a very small number. So we're not going to run into a problem, I think, at all.
Yeah.
So I think we can
So
rely.
So for
I think we can
clarity,
reliably
for
write these
anyone
tests.
that is wondering, we explained at the beginning of this how this sort of works, but the idea is that whatever value you're trying to store in a Bloom filter, you take it and you hash it, and in this case, we hashed it 5 times, and we said, from those 5 times that we hashed it, we got 5 separate values that we modulus down to fit inside of the index, and you'll see that right here. We basically said, take that, make all the indices. So this means hash it 5 times and use a modulus operator to get it down to a specific length. So that lets us make it very deterministic where any value is going to go in our array, in that as long as we still have the same seed. So for that object, we know that that seed is going to be in those, 5, in theory, locations. We will have set them to true at those 5 spots, and then we will do the exact same check, which will get us the same 5 indexes, and we'll see if they're all true. Then that means, yes, we say the value is probably there. So that is our implementation of a Bloom filter.
Yeah, we could change our test to because we did put the constants for the bit width and the hash count. Like we could take the hash count down to like say 1, and we could take the bit width down to like say 16.
And then we're much more likely to have a collision. You want to see a test fail?
That's kind of what I want to do. Yeah.
Yep,
there we go.
When created, when we add a member, when we add more members, the bit array has the correct number of true values. Yep. So because we had collisions even on that small set, and so our check of the implementation failed there even. Was that the only test that failed, though? Yeah, only one failed still.
Yeah.
So that's not bad. And now it passes. And now it fails.
Yeah. and
this
is why.
Yes.
Even doing this, 3 hash counts. A hash count 3 is probably plenty, honestly.
Well, the funny thing is, even doing like a hash count of 2 would have been probably enough with a small thing to cover us.
Yeah.
Although in the width is really what mattered more for that test.
Yeah, well, I mean, they interplay in an interesting way because the width reduces the chance of collision with if you just had one hash function and a really wide bit array, that being wider reduces that chance of collision. But then the increasing the hash count reduces the impact of the collision because it has to collide on all 3 of the hashes in order for it to be a problem. Which is probably why, like when we did it at 16, and set it to 1, the odds of that getting that same number more than once is really high. But if we set it to 2, that probably reduces the odds of.
So the odds
our test
of
is failing,
false
but the
positives
Bloom filter probably isn't.
Yes. So exactly. Yes, that's my point. Is because when you do this, this is just making it really likely that we're going to have bit collisions. But since it requires all of the bits to collide, this really isn't a problem. This just makes it more likely for our test to fail.
Yeah, and which means our tests are actually too brittle.
Yes. Well, one of them. The thing is that no one's going to make this one.
Right.
Because if you needed a Bloom filter, you're not dealing with a set that could have been handled with 16.
Yeah, you're dealing with a set that could have been handled with, like, you're like, hey, I've got 1,000,000 things, and I don't want to do select star from users where username equals.
Yeah. That's the idea. Like, this data structure is intended for something so massive that you don't actually want to, that you need a way of just checking, hey, is this even there at all?
Well, and even this one here is actually a laughably tiny Bloom filter, because keep in mind, if you were implementing this in C, we would be using actual bits and we'd be doing bit shifting, right? And so 1024 is what? 128 bytes?
Uh, 1024 is
Divided by 8
well,
is 128. So
it's 1024 bits.
right. So it'd be 128 bytes.
Yeah.
So I mean, it's tiny, 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 tiny.
Oh yes. What did I type in? Fit ad. Yeah, good old Fit. You know, like on FitHub.
FitHub, yeah.
Actually, that might exist.
It probably does.
Spec, Bloom filter spec. All right. Add data structures. Whoops, not the folder. .js. Okay, so we added those three. What is this? Adding a
Bloom
filter on stream.
Woohoo!
With Guy. Since this will tag
you're right. I'm
looking
at Fuel Snable. Yeah, when you got a petabyte of data, Bloom filters are a good way to limit that.
Exactly. Yes. Yep.
Well, and the thing that's I think is really interesting is that it's like, well, how big's the string I'm adding to the Bloom filter? Don't care. You know, is that a gigabyte of data that you're hashing into a 32-bit number that you're modulusing into the bit width, or is it foo?
Yeah, exactly. You didn't care at all.
It doesn't change the amount of space it takes.
Yep. No, I love that trick. It's just like, does this exist in the system? Yep. Cool.
Yeah. Well, and a lot of the other probabilistic data structures that I've been playing with ultimately use the same sort of trick. They just do it in different ways.
I'm assuming for a lot of these, like many of the use cases would be something along the lines of, I don't want to search this unless I think it's in there. And so if I can avoid looking inside, I will. So the Bloom filter is just a way of saying, you don't need to look because I know it's not there.
Yeah. Yeah. That's absolutely correct.
Yep. Save you from doing
gatekeeper.
work. Yes. Don't do work unless you have to. Okay. So with that, I don't know what your time is like. Do we want to try shoving in a real fast heap or not?
I'm actually I have the wonderful task of replacing a battery in a van ahead of me.
Yeah.
And so
so you're actually going back to that.
What's that?
You're going back to the stuff you were doing earlier.
Yeah. Before stream, I pulled a battery out of our Ford Transit, and because it's dead as a doornail, and now hopefully we went out and bought one. My wife was going to go buy one while I was on stream, and then I'm going to install it back in when I was done with stream. So I need to make sure that one of our, I mean, we have more than one vehicle, but only one of them runs right now, and so I feel better when two of them run.
Understandably.
I would like to do a heap next, though, and
because as soon as we're done with a heap, we can go and do a heap sort, which everyone will be like, wait a minute, isn't that like less efficient than everything else at these sizes? And we'll be like, yes. Inefficient. That's what we said.
Yeah,
I like the fact that we said inefficient.
Yeah. Well, it's JavaScript, so of course they are.
Yes.
And then we'll let someone else do all these in C++. That'd be fine. That's left as an exercise to the viewer.
Oh yeah.
I do want to do some WebAssembly stuff. Maybe I should do some WebAssembly stuff on my own stream and have you on as a guest.
We totally could. Yeah, I want to do some WebAssembly stuff at some point. So the other fun stuff that we talked about. So the binary heap we talked about is a cool data structure. So we should definitely do that next time. There's also the skip list that was the other one that was in our poll, which is another data structure that you can implement in a probabilistic way. And I think that would also be something interesting to build. So all of these are like interesting use case things that if you are in any of the scenarios where you would need this, it's good to know it exists. You
Yeah.
shouldn't implement your own version of it unless you absolutely need to, because very likely there is some library that exists that already did a really good implementation that if you really needed to, you could go and send them a pull request. But don't build these from scratch,
Yeah.
except as a learning experiment.
I mean, I suppose we could do queues and stacks.
We can do queues and stacks, but what I would do is let's have a bigger data structure that is built on a queue or a stack before we make one.
Yeah. Yeah. Well, I was thinking we could use a linked list as a queue and a stack.
I mean, you technically can,
Yeah.
but I think someone's going to shoot us for that.
Yeah. But I actually think a queue and a stack aren't going to be particularly interesting in JavaScript because it's like, well, where would we store them? And we'll store them in an array, but arrays do that already.
Yeah, pretty
So
much. The array in
they got push and
JavaScript
pop and shift
does
and
that. Yeah.
unshift. And so I think they wouldn't be terribly interesting. We'd probably end up creating them as part of something else, like you said. So
Yes.
yeah.
Well, that's I mean, that's kind of the point I would say is like, yeah, like let's figure out what other data structure we want to build and then build it for that. Because despite the fact that an array already does those pieces, you're right. We could do a stack and a queue based on our own linked list, and then they're not like it's really just a layer around that. It's one of those like, yeah, why do you even need that? Okay, we don't. All right, I admit it.
Yeah. But I'd like to dive into some more probabilistic data structures too, because these are interesting and fun. And there's a lot of neat ones out there. And I know how some of them work, and I don't know how some of them work. And I want to know how they all work.
Yeah.
Well, so I want to know how more of them work.
One of the questions that comes up for every time we do these is people asking us, like, why are you building why are you building inefficient ones? Why are you building this? It's like, well, it's fun. You learn about it. That's like, why inefficient? Because it's a lot of like the act of making it efficient is an entirely separate learning and fun experience than writing one. Because it's not so much the understanding of the structure itself and how to use it and how it works, how it's built, but that is how do you optimize the heck out of it, which is a separate thing entirely, and also would definitely not be done in JavaScript. You would I don't care how good you are probably not making a really, really efficient implementation in JavaScript of a lot of data structures.
Yeah. Well, and another thing is that if you're making efficient versions of these, once you go down the performance path, you're not test driving anymore. You might test drive the behavior initially, but then the refactoring to make them efficient and very, very fast is test driving doesn't play with that, right? That's because test driving
it's much harder to test that the performance was good.
Yeah,
without running it massive amounts of time.
Non-functional requirements, really.
Yes. Yep. Exactly. And the interest. So what it reminds me of actually is something that I've had to teach many, many times is the concept of like an IOC container. And I don't know if you've ever done this, Guy, but the way that I teach IOC containers is, first off, I teach people how to use them, but in order to make people like realize this thing isn't magic, I go, all right, we're going to take 10 minutes and we're just going to build one, because like if you don't like test drive it and just want to show like, here, how's it work, and you already know how it works, it's like, yeah, I can just go up there and I'll just be like, boom, here's an IOC container we made in 10 minutes. You saw the entire creation of it. You can see exactly how it works. And it's like, yeah, as soon as you see a data structure built or any other kind of structure built, you're like, oh yeah, that's not magic. No, it's like, no, it's not magic. The Bloom filter's not magic. The linked list isn't magic. The hash table's not magic. None of these are magic, which is cool.
Yeah, just well, and I don't have a proper computer science degree, and so I'm finally getting into data structures, which is something I kind of avoided for most of my career. So, it's been cool going through these things. So
thank
you for the compliments on my beard. I grew it myself.
Yeah. So yes, exactly. So the question that you asked there is what are some magical data structures? And one of the ones that I think some people find to be magic is the hash table that we did, because the hash table does sort of seem like magic
Yeah,
because it kind like if you don't know how it works, it kind of seems like it's just wait a minute, like how can you like have a structure that's not enormous but can index by any value you give it and is still fast to get to the things you need. It's like, oh yeah, no,
yeah.
like
Uh,
no.
I was talking to my boss the other day, and he says there's a thing called stochastic data structures, which I feel like I want to look at. Um, he said they're really fascinating, but they don't really have any use, which sounds like a great thing for us to build on stream.
I do want to build some that have like this has a use. It's not going to apply to most
Yeah,
scenarios, but it has a use. And the interesting thing about this is that you can absolutely see the use of this
yeah.
like immediately, and you could even adapt something similar to this in other places. So
It'd be interesting actually is to build a bloom filter in WebAssembly because that could perform.
that's
Uh,
true.
the real question is you have a need to have a bloom filter in a browser?
Yeah, if well,
And you
if you
might.
wanted to, no, I can actually think of a scenario. For example, our friend Steve Smith, our Dallas.
Yep.
For example, if he wanted to find out, do I have this URL open in one of my petabyte of tabs? That's how he could find out. He keeps about I don't know, like 10 million tabs open at any given time in Chrome. So I could absolutely see him needing to find out, do I have this tab open? Well, we could,
Well,
can you make,
that's one way to live your life.
I think there are a lot of people that do that. Like I know so many people that do the
Sure,
thing where it's like, why do you have so many tabs open? I keep like two open and I'm closing them all the time. And they're like, I keep these open so I can go back to it. I'm like, I bookmark it or save it somewhere and close the tab. Like,
yeah. I actually create a homepage on all my computers and set Chrome to open a homepage on my hard drive. And if there's things I want to keep that I keep going back to, I just put links in that homepage.
yeah, that works.
And so my browsers always start up with Guy's super awesome homepage, and it's just got a bunch of categorized links that I use all the time.
I'm assuming it's full of marquees and blinking things, flaming text, glow
It's got like
effects.
spinning swords,
Sweet.
it,
Do you have like
links to
text trailing the
GeoCities.
cursor as you move it around the screen?
Yeah, I miss the early web sometimes.
Oh yeah. No, I agree. The internet of the 90s and early 2000s was a wonderful place for anyone that got to experience it.
Um, I've been a talk I've had in mind for a while, and a friend of mine ended up doing this talk. We created retro tags for with web components, so you can create new web tags with web components. And so we brought back like marquee and blank and stuff like that. So you get these old school tags back in HTML.
Oh yeah. That is the silliness, is like you're like, why did you deprecate that? It was so good. So good.
So good.
But you also, I also kind of sit there and go like, yeah, maintaining those in the language and having them work with it, it's like, yeah, they
You know,
should disappear. No one should really be using them.
but do the browsers still recognize them?
I thought some of them still did for a little while.
Yeah, because it's like, you really want to take a
I
feature out that
forget.
someone's expecting to have there.
Uh,
It's like in Java. I know you're not a Java dev, but Java's got the Java util.date library
there
has
you
like
go.
all these things that have been deprecated since the 90s.
Yeah. So I'm here looking at the blink tag. Says Firefox 22 is the last Firefox that had it. Opera 15 had it at some point. So blink tag's been gone for a while.
I bet there's a polyfill for it. Probably right. cool.
Yep. I thought that was good.
Yeah, that's really funny.
No.
I
Okay,
like
so
the. By the way, Cyrilish, is that how you say it?
I always said Cyrillash, but I have no idea.
Cyrilash. Um, I like that you mistakenly spelled it bling. I think there
Yeah,
needs to be a bling tag
I
um,
agree.
that like makes things shiny.
Shiny, I don't know. You can. There's all kinds of stuff you could do on it.
Yeah,
Bling tag would be fantastic.
yeah, bling tag. That's a great typo.
Yes. Okay, so we want to do this again. So
Yeah,
tentatively, do you want to say like roughly 2 weeks from now we'll do the next one?
yeah. We'll say that tentatively. I'm not positive yet.
Tentatively. I'm not penciling it in my calendar. I was just checking with you to see like thoughts on that.
Yeah. I'm game for doing another one in the next 2 or 3 weeks.
Okay.
I don't want to commit to a specific weekend,
No, yeah,
but yeah,
that's why I said tentatively. That
yeah.
means it's tentative.
It's tentative. So I'm not committing. It's tentative, right? Just to be clear.
Exactly. Yes. Yep.
So there is a get bowling polyfill. Of course there is.
Wow.
The internet
Yeah.
has everything.
Good job, internet. Thanks for solving all of the important problems.
Good job, internet. Yeah.
And yes, I see we agree. Like the early web had so much awesome stuff. I mean, anyone that's on it knows the under construction animations, the like just all of the fun stuff. Oh
The flaming
man,
skulls.
yes, flaming skulls, like flaming glowing text, and like just things absurdly moving for no reason.
It's using
Wow,
keyframe
Sirlash,
animation.
yes, I see that. Yeah, fire
Oh, that's
everywhere.
hysterical.
Because fire looks cool in an animation. Like when you could animate these flames, it was yeah. Yay, internet! Glad we spent all the yeah. Oh, the counters. Yes, counters on everything. You needed to know the number of visitors that came to your site, man.
Yeah.
Oh yeah, everybody had,
So
and you
good.
had to pick just the right looking counter too. Couldn't be some bland thing. No, that's gotta be glowing or flaming as well. It's important to know how many people were there. Guest books. Oh my god, I forgot about guest books. Holy crap! Yes,
Remember web rings?
Guy, we're old. I say to the person with the gray beard.
Yeah.
Yes, yeah, exactly. If your visitor counter was not flaming, your site was not definitely wasn't hot. No one was going
Yeah,
there.
yeah. We wax nostalgic.
Yeah, guest books. Holy crap! I don't even know what the point of that was. Guest books. Okay, so
Yeah.
in that case, I think that it is about time that we do the old
The credit and rolls and credit
yes,
and raid.
the wrap things up. So for those of you that don't know, this is a regular stream. DevChatter has existed for a little over 2 years now. Like what 2 years and like 3 months or something like that. We've been doing DevChatter streams. Obviously, my name is Brendan, and I am the host of the stream. We have our lovely guest Guy up in the corner, who is always fantastic every time he is here. And we've been doing this series that is our inefficient versions of data structures in JavaScript that we've been doing here on the stream a few times. So this is our third one, and we will definitely be doing more of these at some point. Sounds like we're thinking that it might be like 2+ weeks from now.
Yeah. Well, maybe we could start taking turns on our channels.
We absolutely could. And what I was actually going to mention is that Guy also has a Twitch stream, and if you want to know where it is, Guy is both on Twitch and on Twitter, both, not just one, not just the other. And what is it? It's Guy Royse.
Yeah.
Like that, I think, if I didn't typo it. So make sure you go and give him a follow on Twitch as well.
Yeah, it was
because
just
he streams on Fridays usually. My streams used to be on Mondays, Tuesdays, Thursdays, and Saturdays, but my schedule got a little wonky, and the time that I would normally stream is now full of meetings for work. So I don't stream during the week. I stream on Saturdays only, and I occasionally get in those weekday streams. So I'm going to try to do some more of those, as my schedule is actually starting to give me a little bit more freedom on those. Um, yeah, so the @
so.
usually means Twitter, but no, Guy is on both, and I am obviously on Twitter as well, and you can go ahead and find that one. You should follow us both in both places. That's a good way to get notified when all of this stuff goes live. For anyone that is also interested, down below the stream, you can find links to our Discord and other things like that, and both Guy and I are in there, and a whole bunch
Yep.
of other developers. So if you want to chat with either of us, that is a decent place to have a conversation about whatever cool tech stuff you're interested in. And by chat with us, I mean it's like chat rooms. You remember the internet back in like the 90s? How they had like chat rooms and stuff, like everywhere. Yeah, we brought that back with like Slacks and Discords and things like that. So if you want to enter a chat room and talk with other developers about fun stuff like coding and programming related stuff, that's a cool place to do it.
Yep. And
Yeah,
I've
see,
been
Yahoo.
sorry.
No, go ahead. Chime in with something.
And I've been making a point to try and be in Discord a lot more often than I used to be. It was just a matter of trying to remembering to launch Discord whenever I turn my computer on. And so now I'm in there all the time. So at me on there.
Fuel Snable, that is
Yeah.
that is a hilarious comment to make, considering that you're talking in IRC right now. Like, that message was sent into IRC. For those of you that don't know, the implementation of Twitch chat is actually IRC. So that is the best part about Fuel Snable asking for IRC. Bet you didn't know that.
Actually, I didn't know that either.
There you go. Yeah. So you can actually take an IRC client and connect to Twitch. So Cyrilash, yeah, technically it's the way that the bots connect because you're going in through the web, but it is an IRC chat in that all the bots that receive it and a lot of the other like non-web implementations of it still might be connecting to the IRC version. Yes, I know you. Yeah, you. Yes, you meant the old IRC servers that we used to all use. Okay, so what is there anything else that we need to mention about you or us? What time's your stream on Fridays so people know?
So actually, my stream is every Friday from 2 to 4 p.m. Eastern time. So that'd be
so US.
Yeah, Eastern time US. Yeah, so that would be 6 p.m.
It's
to
1800 UTC is the start.
Yeah, 1800 UTC. And I'm also going to start streaming on Monday nights, 7 p.m. to 9 p.m. Eastern time. And on Friday right now, I'm working on a thing called literal classification, and I'm working on building a little app for you to generate 6 random ability scores for Dungeons and Dragons, and then you can pick the class that you think that should be, and then I'm going to gather a bunch of data, build a machine learning model, so that you can type in your ability scores, and it will tell you which class you could play. And I'm going to be hosting that on Redis AI. So Redis has got an AI thing that we're going to use to do that. On Monday nights, right now, I'm working on a MUD that's backed by a graph database. And so it's a text-based MUD. You go in there, I think multiplayer Zork, and a little web client uses WebSockets to talk to the server, and it's just text-based. And so I've been working on that. I haven't worked on that in a few weeks, but I added a night on Monday nights to work on Redis MUD. And so those are the 2 things I'm working on right now, and then whatever else strikes my fancy. But
yep.
So Monday nights and Friday afternoons.
For those of you that really liked the old internet, Guy is bringing it back.
That's right.
With MUDs.
Well, it's you don't need to tell them that. It's the web client does it via WebSockets. I'm trying to figure out how to deploy it so that we can actually play it, because I think it'd be really fun to work on it while people are playing it. but we're not there yet. So right now you can't even log in. It just you can move from room to rooms, and that's pretty much it. So
Yep, it's an awesome concept. Okay,
and the graph
let me.
database stuff is really really cool. So
To be honest, I need to check it out more.
yeah.
I'm gonna roll some credits.
Okay.
So I want to make sure that I thank our moderators for hanging out and helping out with the chat today. So thank you to S&B, that moderator Guy Royse, and Stoolpenner for hanging out with the stream. Thank you to these lovely people who followed us here today. And I want to make sure that I thank our subscribers, S&B and Echo Strike, both for showing up and clicking the button to make notifications to share the fact that they're subscribed. We will be back at some future date, 2 or 3 or 4 or 5 or 6 weeks from now, probably on a Saturday to work on more data structures. But until then, you can find me here regularly on Saturdays or the occasional random midweek stream, which you'll want to be following me to get notifications of, or on Twitter or Twitch. And you'll find Guy on Monday evenings and Friday afternoons on his channel, which is Guy Royse, which is written right below his name, and we linked a couple of times in chat. So we look forward to seeing you all at one of those future streams that we're doing, and thanks for hanging out today. Happy coding,
Cool.
everyone.
Bye.